So for homework 3, which is a mass balance, we're gonna, just for part 1, we're basically gonna derive our governing differential equations for the given liquid heights for the tank. So let's go ahead and draw the tanks first. We have tank 1, which is at a given height, which we'll call H1. And then we have a tank 2, which is at H2. And we have a flow, which we'll call Q1, that goes into tank 1. And then that flow will go from tank 1 to tank 2, which we'll call Q12. And then it'll then exit tank 2 at Q2. Okay? And based on our equations, we know that Q12 is going to be equal to, we'll just call alpha 1 square root of H1 times H2. And then, or minus, sorry. And then the other one is going to be Q2, which is going to be equal to alpha 2 times the square root of H2. And we know that the density is constant in both these equations. So first we're going to look at tank 1 and look at the volume of that. So we know our tank 1 volume is equal to the area of that tank times its height. And basically for our rate of change equation, we're going to write our derivative. So we're going to do d times the area times h1, which is the a1 and h1, over dt is going to be equal to basically what's going in minus what's going out. So we're just going to call that Q1 because that's what's going in tank 1, and then subtract Q12 going out. Okay. So we know that our area is going to be constant here, so we can go ahead and take that out of the derivative equation and divide that over to the other side. So we'll be left with dh1 over dt is going to be equal to q1 minus q12 over a. And we're going to do the same thing for our tank 2 volume, so we'll just say tank 2 volume is equal to area times height. And same for rate of change here. dA2, area 2 times the height 2 over dt is going to be equal to what's going in minus going out. So here we have Q12 going in, so minus Q2 going out. And we go ahead and divide the area over again. Yeah, so that's our derived governing equations. And for this case, we can go ahead and write out the numbers that we're going to use in the Python later. But we know that our A1 is going to be equal to 1 meter squared. We know that our A2 is going to be equal to 1.5 meters squared. We know that our alpha 1 is going to be equal to 0.5. Our alpha 2 is going to be equal to 0.25. And for the heights of the tank, we know that our first height is going to be equal to 2, and our second height is going to be equal to 1.5. And that's it.